Hello viewers, I am Kausalya. Today we are going to solve some more problems in exercise 6.2 chapter 6 triangles. Here I start with problem 4. You see this is the given diagram. So here from this diagram you see DE is parallel to AC and this DF is parallel to AE and we have to prove this condition. Right. So here for this we have to consider two triangles. First I am considering the triangle ABE. So when you consider the triangle ABE, here it is clearly given, right? DF is parallel to AE, right? So this DF is parallel to this AE. So draw the triangle separately, right? So since these two lines are parallel to each other, when we use basic proportionality theorem, AD by DB is equal to EF by FB, right? So mark it as equation number 1. This is purely based upon the basic proportionality theorem. Now what is the next condition given over here? Here it is, you see DE is parallel to AC. So here I am considering the bigger triangle ABC and I am considering the line this DE which is parallel to AC, right? So this is our second triangle, right? So here again, since these two lines are parallel, again we are going to make use of basic proportionality theorem. So according to the theorem, you see AD by DB is equal to CE by BE or AB, right? So when a line is parallel to the third side of the triangle, it divides the sides of the triangle in the same ratio or in same proportion, right? That is known as basic proportionality theorem. Since these two lines are parallel, then obviously the sides should be proportional. That's why we are writing in the form of ratio, right? So name this as equation number 2. So when you consider equations 1 and 2, you see here also AD by DB and here also AD by DB. Since the left hand side terms are equal, obviously the right hand side terms should be also equal, right? So here when you equate, you see equation 1 is equal to equation 2. So we can ignore the left hand side. We are considering the right hand side because left hand side term is same. So EF by FB is equal to CE by EB, right, or BE. So when you take reciprocal, here comes FB by EF equal to BE by CE. So again, according to the problem, we are just changing, right? FB is, we can write FB as BF also. So BF by FE is equal to BE by EC. This is what was in the problem, right? And finally, you can write hence proved. So now problem 5. In figure, DE is parallel to OQ. So this DE is parallel to OQ and DF is parallel to OR. Show that EF is parallel to QR. Right. So again, as the conditions are given, so as per the given condition, we have to segregate the triangles. So here DE is parallel to OQ, right? So this is parallel to this, right? So as a first part, I am considering this triangle POQ, right? So when ED is parallel to OQ, we can apply our basic proportionality theorem, right? Even you can hide like this, right? This is my triangle, right? I am considering the triangle POQ, right? And ED is parallel to OQ. So when you apply basic proportionality theorem, how can you write this? PE, right? PE by EQ, right? That is this part. PE by EQ is equal to PD by DO, right? So this is what I had written here. By using basic proportionality theorem, this is our first condition. Not first condition, this is the first equation which we are framing. Now again, what is the second thing given? DF is parallel to OR, right? This is DF and this is OR. So I have to consider the triangle POR, right? And again, as usual, you can hide this part. So, right, so this is the triangle POR and again DF is parallel to OR. So you can apply your BPT. So here what is that says? PF by FR is equal to PD by DO, right? So this is the thing I had written here. Again, you see here also I have PD by DO and here also I have PD by DO. So when the left hand side terms are equal, obviously the right hand side terms should be equal, right? So 1 is equal to 2. So when you equate this, PE by EQ is equal to PF by FR, right? So what is this condition? We have to check this condition with our diagram. So PE by EQ, right? So what is that? PE by EQ is equal to PF by FR, right? This is by converse of basic proportionality theorem. That is, the ratio of the sides of the triangle are equal. Right, whenever the ratio of the sides of the triangle are equal, then obviously this side is parallel to this side. Right, EF is parallel to QR. Right, so this is what we are expected to prove. So when this ratio is equal, right, by converse of basic proportionality theorem, we can conclude that this EF is parallel to QR, right? Now problem 6. In figure A, B, C are the points on OP, OQ and OR. Okay. So here we have triangles, right? So A is a point on OP. A is a point on OP and B is a point on OQ, right? On OQ, B is a point and C is a point on OR, right? Such that AB is parallel to PQ. You see, this AB is parallel to PQ and AC is parallel to PR. Then we have to prove that this BC is parallel to QR, right? So this is the given data and finally we have to prove that BC is parallel to QR, right? So first, what is the thing given? AB is parallel to PQ, right? So AB and PQ. So these two lines are a part of the triangle OPQ, right? So only from the given data we have to select the triangles. So OPQ, right? So this AB is parallel to PQ. By making use of basic proportionality theorem, we can write that OA by AP is equal to OB by BQ, right? So this is purely based upon basic proportionality theorem. Okay, when a line is parallel to the other side or third side of the triangle, then obviously the ratio of their sides are equal, right? So again, what is the next condition? AC is parallel to PR. So here is my AC and here is my PR and these two lines are a part of the triangle, this one, okay, POR, right, or OPR, whatever may be. So again here, as these two sides are parallel, we can make use of the basic proportionality theorem. So when you make use of this, you can write it as OA by AP is equal to OC by CR. Right. So mark it as equation 2. Again, by using basic proportionality theorem, we are writing like this. So when you compare 1 and 2, you see the same left hand side terms are equal. Here also OA by AP and here also OA by AP. When left hand side terms are equal, obviously the right hand side terms must be equal. Right. So therefore OB by BQ is equal to OC by CR. Right. So now we are going to compare this OB by BQ. You see here OB by BQ is equal to OC by CR. Right. Again here we have to make use of converse of basic proportionality theorem. Right. When the sides of the ratios of the triangle are equal, then obviously this line is parallel to this line. Right. So you see here finally we are concluding. This implies BC is parallel to QR. Here we are making use of converse of basic proportionality theorem. Right. Now problem 7. Using theorem 6.1, which is basic proportionality theorem, Prove that a line drawn through the midpoint of one side of a triangle parallel to another side bisects the third side. Right. So here the thing is we have to prove that a line drawn through the midpoint of one side of a triangle. Okay. Let the triangle be ABC and D is the midpoint of AB. Right. Now a line drawn through the midpoint. So this is the line which is drawn through the midpoint of this triangle, midpoint of one side. Okay, midpoint of the side AB of a triangle. And this line is parallel to this line. Okay, you see, parallel to another side. So this line is parallel to this side of the triangle and this bisects the third side. So this is my third side, right? You see, I'll repeat. AB is one side of the triangle and D is the midpoint, right? So a line drawn through the midpoint of one side of the triangle, this line is parallel to another side, right? And the line which is drawn through the midpoint, it bisects the third side, right? So this line bisects this side. Okay, this is the thing what we need to prove. So first, you see, we are starting from the given conditions, right? So in triangle ABC, you see this DE is parallel to BC. Okay, this is parallel to this. So here when we make use of basic proportionality theorem, we can write the sides ratio as AD by DB is equal to AE by EC, right? Name it as equation 1. And the second thing is, here in the statement it is clearly given that D is the midpoint. So when D is the midpoint, we can write AD is equal to DB, right? So here mark it as equation number 2. Now we are going to substitute this 2 in 1, right? Because it has both AD and DB. So when you substitute over here, right, what happens? AD is equal to DB. So I am replacing AD by DB. So these two terms cancel. And finally we have AE by EC is equal to 1. So when you move this EC to the left hand side, 1 into EC is EC. Therefore here AE is equal to EC. So when you look this condition in the triangle, you see, here AE is equal to EC. What do you mean by that? E is the midpoint on the side AC, right? So what we need to prove? I repeat, a line drawn through the midpoint of one side of the triangle. So AB is one side of the triangle and D is the midpoint, and through this midpoint a line is drawn, and this line is parallel to another side, this side, and finally this line has to intersect the other side, that is the third side. So here what is the conclusion? AE is equal to EC. What does this mean? This line DE intersects the line AC at the point E, right? So finally we had proved that this line bisects the third side, right? So finally you see, you can write the statement, that is A is equal to EC. So this shows E is the midpoint of AC and the line, okay, the line DE bisects the side AC, right? So that's all in this video. If you have any doubt, let me know in the comment section. Thank you.